Hello everybody, I am Zach Peterson. Welcome back to my channel. Today I'm going to talk to all of you about the 4 best ways to start learning PCB design and to start growing in your career as a pro PCB designer. Now, I get a ton of questions about PCB design. I feel like my emails and my LinkedIn inbox and even the comment section on YouTube is flooded with questions, and I can't get to all of them. But one of the most commonly asked questions that I see is how to start learning PCB design. So I'm gonna run over the 4 strategies that I found work best for new designers, and these strategies can help you grow in terms of your skill set and in professional development. Let's go ahead and jump in and get started. Now, as I mentioned in the introduction, one of the most common questions that I get on my videos and on LinkedIn and in my email is where to start learning about PCB design. Let's take a look at some of those comments. On our obsolete components warning 1-minute design review video, DRock5288 writes, "How do you get started learning to do this type of work?" Here's a comment from our 3 steps to route microstrips in Altium short. Zach Peterson, I was hoping you could make a video for those that want to go into PCB design now. Basically for beginners, sort of like a roadmap with what we should start with, materials that we could use, whether books or videos, courses that we should take. It will really help. And we have the same guy leaving a comment on our power supply tips analog versus digital pins video on Altium Academy. He writes, "Hey Zach, can you make a roadmap video for those that desire to learn circuit and PCB design?" Here we have a comment from Rahul Panwar 6050. Rahul writes, "Hello sir, I am inspired by you, the way you explain things." Well, thank you, Rahul. "Can you tell me how I can learn hardware design? Reading data sheets and a lot of stuff goes above my head, but I am dedicated to learn how hardware works." Shreya Sala sent me this message on LinkedIn. She writes, "Hello, Zachariah. I am Shreya and I have recently started my career in PCB design. I have taken an Altium course and also have done my very first board, and I have developed an interest in this field. My colleague was just talking to me about how this PCB design is like an art, and it is beyond it. It is indeed an art and a science. I want to do more boards and learn about this. Can you please guide me?" Philip Chichowski writes, "Hello, Zachariah. I want to learn PCB design for power electronics devices. I need to learn Altium too. Would you stick to tutorials provided by Altium at the beginning, or would you supplement it with some books? If so, do you have any opinion about the Circuits Handbook 7th edition by Clyde Coombs?" And this is our last question, coming also from LinkedIn. Adam writes, "Seeking your advice on learning PCB design. Hi, Zachariah. I hope you're doing well. I've been following your work and really appreciates the insights you share about PCB design and hardware development. I'm currently working on improving my PCB design skills and have been learning a lot from the Altium YouTube channel. I was wondering if you might recommend any other good resources, books, online courses, communities, or creators that you think are especially helpful for deepening PCB design knowledge." Now, this is just a small number of the questions that I've received, and you see 2 common themes within those questions. One of those is, what courses should you take? And number 2, what books should you read to help you learn about PCB design? I think there are really 4 good paths forward. One of them is courses, another one is books, but then there's also conferences as well as open source projects. So let's get into each of those strategies to learn PCB design. First, let's take a look at PCB design courses, and I'd like to lump tutorials in with courses because, of course, some courses will leverage tutorials from external creators, and some creators that create tutorials, for example, on YouTube, also have courses. Also, thanks to all of the resources that are out there for free on YouTube, you can even create your own course of sorts just by compiling together various tutorials from well-known creators. Courses generally fall into two types of courses: Some of these courses are tool specific, where you're really learning to use the CAD tool itself, and you're focusing less on things like manufacturing and engineering. And then there are other courses which focus more on the engineering, manufacturing, and less about the tool usage specifically. Now, of course, if you take an engineering and manufacturing type of course, you will learn a little bit about tool usage, but that's not necessarily going to help you become a power user of a particular tool. So I have a few examples of some different types of resources that can help you both on the engineering side as well as the tool usage side. Here I am on the education.altium.com website, and you can see here that Altium offers a course for learning printed circuit board design. And if you are a university student, you can get a student license of Altium Designer when you enroll in this course, as long as you have a valid educational institution email address. Now, I really like this curriculum. Number one, of course, I helped create it, so I'm a little biased, but I also like it because we tried to get a good middle of the road course together that helps people understand both the engineering side as well as the tool usage side. So you will have an opportunity to create a power regulator project inside this course, and that will help you learn some of the deeper aspects of the tool, but you also get some overview of some of the basics of PCB design and layout and routing, as you can see from these 6 units. So you get an introduction to PCB design, you get an overview of manufacturing, and then you actually get a walkthrough of doing things in schematics and libraries, the PCB layout and routing, and the basics of signal integrity. Now, again, in this course, we try to balance some of the engineering topics right alongside the tool usage topics. So what we do is we present the engineering concept, and then right alongside it, we show how to implement the engineering concept inside of Altium Designer. Now, most of you know me from the Altium Academy channel, and of course, Altium, I think, is really the best tool out there, and it is the most popular tool as well, just based on the number of designers who use it. And I think it's really important to start learning one of the more popular design tools because, of course, when you start to go out and look for a job, it's highest probability that you will end up finding a job that uses the most popular tool, just because that has the largest number of people using it. If you want to go a more tool agnostic route, there are other resources that you can find online, both as formal courses, as well as a collection of tutorials that you can use to learn more about important concepts in PCB design. Now, of course, if you're watching this video, you've probably already subscribed to my YouTube channel, and if you haven't, make sure to hit that subscribe button, and you'll be able to keep up with the tutorials that I produce, some of which are tool agnostic and some of which do focus on specific software usage. If you want to look at some more tool agnostic options, Altium Academy is not just full of Altium tutorials. We do actually produce tool agnostic videos that help you learn about the concepts and practice of PCB design and engineering. Another option for learning the concepts and engineering is to go with Phil's lab. Phil Salmony is, of course, also a contributor to Altium Academy, and he has produced a course called Advanced Digital Hardware Design. If you go over to philslab.net, click on the courses button, you'll be able to go find this link over to the Fedival education page, and you can enroll in Phil's course. Now, you'll also see here, if we scroll down, he also has a mixed signal hardware design with KiCad course. And so again, this is going to be focused more on KiCad rather than Altium. And you can see here, this is also on the Fedival page. Now, I think Phil's courses are really great because they do bring more of the engineering concepts into the mix, and you'll have an opportunity to produce projects. But of course, KiCad being an open source software package makes it very easy to get into a design tool and start learning how to design PCBs without paying for a software license. Another option for hardware design courses is to head over to hasofu.com. Here I'm on the academy.hasofu.com webpage, and you may know Hasofu as the company that is run by one of the Altium On Track podcast guests, Kirsch Mackey. Here, Kirsch has created a really great set of resources for learning hardware design from scratch. You can see here that there are online courses, there are practical tips and training, and then you can see here we even have a forum for discussing with other members of the community. Now, I mentioned Altium Academy earlier as one of the resources on YouTube that you can use to find tutorials, both engineering specific as well as tool specific, but what are some other options available on YouTube? Well, here I'm on YouTube on the Phil's Lab channel, and you can see here Phil has a ton of different videos all about PCB design and hardware design more generally. You can see here he already has an FPGA plus PCIe hardware accelerator design walkthrough right there on the front of his page. So I encourage you to go over and subscribe to Phil's Lab. Another channel that is new, and it's a company that I've just started working with, is Dentaflux. Now, Dentaflux focuses on EMI and EMC, but of course, if you're ever going to be working in PCB design professionally, at some point you are going to have to encounter how to overcome challenges related to EMI and EMC. Now, Dentaflux is an EMC analysis platform that basically looks at your PCB layout and your specification and identifies potential sources of EMI. Their channel features myself as well as many other experts in the EMC space, and they're going to be uploading many different resources, including some of their masterclass sections on their YouTube channel. So I encourage you to go over to the Dentaflux channel and check it out. So that covers the list of hardware design courses that I would recommend to a new PCB designer if they want to get to the professional level. But what about books and even other publications that you'd find online? Well, let's take a look at some books that I would recommend designers look at. Here I'm on Amazon, and you can see that I have brought up the Signal and Power Integrity Simplified book by Eric Bogatin. Now, if you're not familiar with who Eric Bogatin is, he is the technical editor of Signal Integrity Journal, and he is a professor at UC Boulder, and he is well known as a signal integrity expert. In this book, you're going to learn about signal integrity and power integrity and some of its relationships to EMC. Now, one of the things that I like about this book is that it's good enough to help designers who are new to the concept of signal integrity understand why we have to worry about these things and how to approach it in your PCB. But it's also good because it takes those concepts into the gigahertz range, which is really important because that covers a lot of the standard high-speed interfaces that you'll find on most digital processors. Next, let's take a look at the Printed Circuits Handbook, 7th edition by Clyde Coombs. Now, this book was mentioned in one of the comments. Now, it is about 10 years old at the time of making this video, but I think it is still very relevant for PCB design today. This book covers design methods and fabrication. It also offers a lot of guidance on printed circuit engineering, soldering, testing, and repair. So this is really a great book that gives you an all-around view of what PCB design is and what PCB designers have to do to create electronic products. Next, I have some hard copy books that I would like to show you that I think are really excellent. Here, if you're interested in RF circuit design, you can pick up the RF Circuit Design textbook by Chris Boswick. Now, this is, again, a circuit design book, so it goes over a lot of the circuit design theory, including transistor circuits, passive circuits, and a variety of other printed circuits. Now, since most designs are approaching higher and higher densities, and of course often use BGAs, I think it's great to understand BGA breakouts and routing, and that's why I have here the BGA Breakouts and Routing 2nd edition book by Charles Field. Now, this book approaches using BGAs from two perspectives. One of them is the breakout or the fan-out design and routing, and then the other is how that relates to manufacturability, which is of course very important because if you can't manufacture the PCB, then there's no point in designing it. The last hard copy book that I'd like to look at is one that was given to me recently by Martin Gaudian from Polar Instruments. This is the Printed Circuit Designer's Guide to the Secrets of High-Speed PCBs. Now, this is a really excellent book because it's going to help you understand what happens in simulators and how to interpret some of the results from simulators, as well as some other aspects of high-speed PCB design. Now, this is a bit more on the tool-specific side because Martin Gaudian does work at Polar Instruments, and this book does show some examples using Polar Instruments software, but it is still a great overview of some of the concepts that go into high-speed PCB design. Now, this Secret of High-Speed PCBs guide is not the only book that you'll find in this Printed Circuit Designer's Guide series. If you go over to iconnect007.com, you will see many books that you can access from their website, as you can see here on screen. You have topics relating to process control, flex and rigid flex, thermal management, all sorts of manufacturing topics, materials, stack-ups, really anything that you can imagine, all written by experts who have been working for years in the field. Next, I want to look at 3 online publications that I think are really great, and you should definitely go and subscribe to these publications if you want to learn about PCB design, as well as keep up on the newest technology and industry developments. First, we have Microwave Journal. Now, I am subscribed to Microwave Journal. I really like the content that they provide, and I think they really do a great job of keeping me up to speed on some of the newest developments in RF and microwave design. The sister publication to Microwave Journal is Signal Integrity Journal, and Signal Integrity Journal focuses more on high-speed digital design, and you'll find a lot of really great white papers and articles on this publication. And the third publication I would like to highlight is Printed Circuit Design and Fab, which is published by PCEA. Printed Circuit Design and Fab provides industry news, educational articles, and they even have a PCB chat podcast. Now, of course, these aren't the only online publications. There are other magazines such as electronicdesign.com, allaboutcircuits.com, powerelectronicsnews.com, many other online publications that also publish industry news and educational articles. So if you're watching this video right now, head down to the comments section and let me know your favorite online PCB and electronics design publication. Now, online courses and books are great, and I think in today's environment, they're really mandatory if you're a new designer and you want to get to a professional level working in PCB design, because unfortunately, colleges and universities, especially here in the US, do a pretty terrible job of offering resources to students who want to get into this field. But if you really want to get to the professional level and grow as a professional designer, there's one thing that you really should do, and that is attend industry conferences. Here in the US and in Europe, there are many different conferences that I would recommend attending. Of course, if you're in Europe, there is Embedded World and Electronica and Productronica, all really great expos for learning about PCB design and hardware design more generally. Here in the US, there are 4 events that I really recommend people attend if they want to grow and learn as PCB designers, and of course, they offer chances for networking, meeting vendors, and getting technical questions answered. The biggest one here in the US that focuses specifically on PCB design is PCB West. PCB West is held in Santa Clara, California. It's been going on for as long as I can remember, and I've been speaking at PCB West for the last 6 years. Now, PCB West is a 4-day or sometimes a 5-day conference, and it covers all sorts of areas, including manufacturing, signal integrity, simulation, thermal, really anything that you can imagine. If you want to learn about PCB design, you should definitely come out to PCB West. Now, if you can't make it to the West Coast of the United States, you could, of course, head over to PCB East. PCB East is held in Massachusetts, outside of Boston, and it's a bit of a smaller conference, but it has been growing over the past few years. And you can also get access to similar resources as you'll find at PCB West. For example, again, manufacturing, signal integrity, power integrity, simulation, thermal management, all of those types of topics, you can learn about them at PCB East. One of the biggest conferences that happens in the US and that really attracts people from all over the world is DesignCon. And I have yet to attend a DesignCon because unfortunately I've had a lot of family things that have come up or a lot of professional things that have come up right around the time of DesignCon. So I am itching to get out to a DesignCon conference. But I really recommend that anyone who wants to, again, develop and grow as a PCB design professional, you head over to DesignCon. It is also held in Santa Clara, California. The next conference I want to highlight is IPC Apex. Now, Apex is one of the biggest conferences, again, here in the US. It is an in-person conference held in Anaheim, California, and it focuses more on manufacturing than it does design. But of course, if you are a PCB designer, you do need to know about manufacturing because, like I said earlier, if you can't manufacture it, then there's no point in designing it. This also offers a trade show where you can network with other professionals, meet vendors, and get your technical questions answered. Now, of course, these aren't the only in-person events that you can find out there in the wild. There are other events from other organizations, such as from IEEE. There are, of course, PCEA chapters that hold local events, and there are even online conferences that you can attend. Many of them allow you to attend for free. One of the best online conferences, in my opinion, is EDICon. Now, EDICon is an online conference that focuses on some of the more cutting-edge areas of electronics design, package design, and PCB design. As you can see here in the program schedule, we have topics on substrates, we have topics on automotive, we have topics on radar, a whole variety of topics that, again, push on the more advanced boundaries of PCB design and electronics design. It is free to attend, and you might even see me giving a talk at an EDICon conference. Now, I think conferences are extremely important for networking with your peers, brushing up on the fundamentals, and staying up to date with the newest advancements in PCB design and electronics design more generally. But I'd like to offer one additional idea for learning PCB design, and this is based on how I learned PCB design. I've found that the best way for me to learn something new is to find a well-documented example and then reverse engineer it, and that's exactly what you can do if you want to learn PCB design, and you can do this from open source projects. You can find open source projects online, you can take those schematics and then use PCB design software to create your own PCB layout from those schematics. This is great because it gives you an opportunity to learn how to use PCB design software, as well as you can see how to implement engineering decisions inside of the PCB design software. But where can you find these fabled open source projects? Well, I've got two ideas for you right here on screen. First thing you can do is you can head over to GitHub. If you go to github.com, you go to the top search bar and type in PCB, you're going to get 100 pages worth of results. Many of those results are complete, ready-to-use PCB design projects. Just as an example, let's take a look at this FPGA board. Here you can see you have a huge amount of information for this FPGA board, including schematic sheets, and you can see here when we scroll down a KiCad PCB file. Some other stuff that you can find on GitHub includes scripts and libraries, for example, for Eagle. You can access component libraries on GitHub, and you can download them for free and use them in your PCB design software. Another way to find open source projects is just to search for a popular microcontroller. For example, if you want to search for ESP32, you'll find all sorts of ESP32 projects. Again, these are both full PCB design projects as well as firmware that can run on an ESP32. Other resources you can find on GitHub include open source software for building and designing PCBs, and you can even find reference designs for some components. In fact, some companies actually put all of their reference design files onto GitHub for their components so that you can access it for free. Now, whenever you're using an open source project, and especially open source libraries, make sure you do a thorough review of the project or the libraries before you use them and before you build them. One of the things that makes GitHub a double-edged sword is the fact that anybody can put whatever they want out on GitHub, and there's no guarantee that it's been thoroughly reviewed before being published. So make sure to do your own due diligence and review those files before you use them. Now, the last place I'd like to point out where you can find open source projects that you can use to help you learn PCB design is directly from Altium. First, if you go over to CircuitMaker.com, you can access the CircuitMaker design software. CircuitMaker is developed by Altium, and it is basically like an Altium Designer Lite type of application. It is free to download and use, and if you see here on the top menu bar on the CircuitMaker website, there is also an option to access projects in CircuitMaker format. Now, there are a lot of projects on this page. I encourage you to go ahead and download them and take a look, and you can use them inside of CircuitMaker for free. Now, CircuitMaker is a really great resource if you want to learn Altium products, but you can't access a license or you're not ready to buy a license. I really like recommending CircuitMaker to anyone that wants to just learn the process of PCB design while also getting a little bit familiarized with Altium's design tools. Once you're ready, you can then make the shift over to Altium Designer, and the tools found in Altium Designer function very similar to the way the tools work in CircuitMaker. So it's a great way to get you started on using Altium Designer without paying for a license. Now, there is one thing I almost forgot which is reference designs. So here's one example for a Texas Instruments component, AWR2243. And here you can see, of course, there is an evaluation board. And I really like Texas Instruments because they do make a lot of the design files for their evaluation boards publicly downloadable. But you can also go here and look through the list of resources here in a search results page. And you can see here that there is a reference design right here, which can be accessed directly from Texas Instruments website. Now, this isn't the only reference design that you're going to find. Another great example from Texas Instruments is, for example, this power converter. So here, this power converter, they make the schematics and the PCB layout publicly available. And to get access to the schematics, of course, you have a PDF file right here. But if you click this CAD CAE symbol downloadable zip right here, this includes all of the Altium files that you need to access the schematics and the PCB layout for this board. So why do I bring up reference designs? Well, reference designs are really great because they give you access to validated schematics that you can use to create a custom PCB layout. Now, should you follow the advice in the PCB layout or follow the practices in every PCB layout that you see in a reference design? Well, one of the Altium On Track podcast guests, Kevin Coates, has some really important advice on this point. Let's take a look.
I did dozens of eval boards, dozens, and that was my job. And so let me tell you how those layouts, they come up with those layouts by going to the PCB shop that we generally go to, it was Spectrum Digital back in the day and some of the others, and saying, here, lay this out. The TI people don't lay it out, and the silicon companies don't lay it out. They don't have the understanding to do that in general, so they have somebody else do it. Now, of course, it's different if you're doing something like an AMD processor. They get really into their layout, like with Dan Beaker. But for the most part, for like LDOs and BGAs that are just simple processors and things, they don't do that. And that's why they do a bunch of things that, like you said, people take them as gospel, and they took my eval boards as gospel all the time. And I'm telling them, I'm like, this board has not been FCC tested. This board has not been in a product. I don't know if this is a great design or not. It's an example.
So clearly, we shouldn't just blindly follow everything that we see in reference designs or evaluation kits. So I think it's important to use your judgment. But these schematics that you're going to get for a reference design, just like this, you can actually use these as a starting point to then practice your own PCB layout skills. So I think that's a really important thing to do, is if you just focus on the PCB layout, it's going to allow you to bypass a lot of these points in the schematic and just focus on honing your skills for PCB layout. And I think ultimately you're going to learn to do better at PCB design just through practice. So consider using this as a resource to help you learn PCB design and to learn the required software. Thank you everybody for watching this video. If you're an experienced designer and you're watching this video, let me know in the comments how you got started learning PCB design. I know that universities have been a little lax on offering courses on this subject, but I'm expecting that to grow in the future. But I always want to hear from experienced designers how they got started in this space. Make sure to hit that like button, hit the subscribe button, leave your comments and questions in the comment section. And if you leave a great comment, it just might end up in one of these videos. Thanks again, everybody, and we'll see you next time.